Welcome to the lecture on wind, waves, and currents. This first part will be on winds, and I'm going to go really fast because I'm tossing in deserts. It's not really part of the chapter, but I think it's handy to know. This is probably going to be your longest lecture series yet, so here goes. Excuse me. Wind will be the first part. That's kind of a hint. And this is just something to think about. Just respect the rocks, okay, folks? Really. Wind is a big agent of change. It's not as powerful as running water, but running water occurs only in a few places. Wind occurs every place. Let's look at some pretty pictures. This is caused by wind. This is in China. This is, I believe, in Idaho. Remember the center pivot irrigation, where you draw water, groundwater out, collapsing the soil. This is the farm areas, I believe, in Idaho. Here's an old river. You can see the meanders in it, and these are sand dunes. That would make sense. River, deposits, sand. Here's sand dunes taking over a forest, covering it up. Here is dust, not sand, but dust, finer materials which can get blown up to 40,000 feet into the air, drifting off the coast of the Sahara, and they actually make their way all the way to the Caribbean, where they bring in some toxins and are poisoning some of the organisms in the reef. Crazy, huh? Great Sand Dunes National Monument in Colorado. And believe it or not, this is a desert, Antarctica. It gets less than 25 centimeters of rain a year, or precipitation, it's just that it's snow, and what's there stays there, but it really is fairly dry. Okay, where do deserts occur? You know about this. This is the Sahara, and it is getting larger each year. As we pump groundwater out down here and then overgraze this area, you're losing the vegetation, the groundwater or water table is collapsing, and this area is expanding. You can see the delta from the Nile here. This is very cool. Okay, let's look at a world map and then show you where the deserts are. Here, Kalahari, Syrian, Arabian, Karakum, Kavir, Talamancan, Gobi, and the Great Australian Desert. In fact, most of Australia is desert. Sorry, mate. Places with less than 25 centimeters of rain a year, about 10 inches, are in red. Notice, sorry, is that brown? I'm colorblind. Whatever color that is. Places that are close to being deserts are in the yellow. Why do deserts occur in these places? Well, take a look. This is about 30 degrees north, and here is about 30 degrees south. There's something curious that occurs. Air on the equator rises because it gets warm. As it rises, it cools, and as it cools, the particles move more slowly. As they move more slowly, they get close to each other. The air particles, as they get closer to each other, they squeeze the water that's in gas form out, and the water drops back on the equator. So equatorial zones tend to be very rainy. How do we know that? Take a look along the equator. Do you see any deserts? No, in general. That air then goes to about 30 degrees north and 30 degrees south, where it drops. As it drops, it warms up, and it can hold more moisture, but it doesn't have the moisture. Therefore, this dropping air is incredibly dry. What do we see? 30 degrees north and 30 degrees south, we see deserts, places with a lot of wind. Here's another place that you tend to get deserts or a lot of wind. When air rises, again, it cools. As it cools, the particles get closer together. As the particles get closer together, water is squeezed out. So on the windward side of mountains, you end up with a lot of rain. Think of the Mogollon Rim in Arizona. Here's Phoenix down here. Here's Payson. Payson gets a lot of rain. Over here, Winslow, Holbrook, not so much rain because the air coming over has been dried out, dropping all its tears, oh my gosh, on this side of the mountain. So sad. In the southwest United States, we have a rain shadow. Why? All the mountains along the coast block the wind or the air. As it rises, it tends to drop the moisture over here, and we are left with drier air. We have the Basin Range and Colorado Plateau desert areas. Now, notice that very few deserts have through-flowing rivers. Let's go back. How many through-flowing rivers are in this huge area? One, the Nile. In this area, not many at all. You've got the Ural River, I think, dropping down into the Caspian. In Western Australia, no major rivers. No major rivers here. No major rivers down here. You do have one over here, though. And the only river that flows through here, really, is the Colorado, and the Columbia hits a little bit of this. But in general, they don't have major flowing rivers that get all the way to the coast. Two exceptions, Colorado and Nile. Another thing that causes deserts is being on cold western coasts. This is a western coast, and western coasts tend to be cold and desert-like. Okay, the major deserts in the world, this may surprise you, the biggest one, Antarctica, by far, over 5 million square miles. The Sahara, you really shouldn't say Sahara Desert because that means, well, desert. It's like Table Mesa. The Arabian Desert, only 900,000. The Gobi, the Kalahari, the Patagonia. Take a look. When we get down to ours, it's only 190,000 square miles compared with Antarctica at over 5 million square miles. Deserts are typified by immature or very little soil, and the winds remove the soil faster than weathering can create the soil. Often they will have badlands, which are clay soil, and as clay gets wet, it expands, and as it expands, it blocks the water. When it dries out, it shrinks. Plants don't grow well in this stuff. Go to the Little Painted Desert in northern Arizona, not a lot of plants there. This is a picture of it. And by the way, remember a little drawing earlier in the class where I had houses on a cliff? People really do build like this. And these slopes, because they're clay, can erode backwards, headward erosion at about 4 inches a year. So building right at the edge doesn't make a lot of sense. This is up in northern Arizona between Winslow and Holbrook. And deserts often have slot canyons because the rain is episodic. That means it comes quickly and then it goes away. It's not like Louisiana where you have rain and lots of rivers every day. Again, here's the Great Basin Desert. Yes, I know I'm going fast, but you can slow it down if you need. Here's the Colorado Plateau. Here's the Mogollon Rim. Winds that come along here drop the rain and it drops back down this way. This tends to be desert. In deserts, you often find salt flats. Now, the dust storms, the 1930s, John Steinbeck, the Grapes of Wrath. Farmers had for years plowed and plowed their land. They would leave the land uncovered by vegetation in between the plantings. Not a good idea. Nature never does that. Along came the 1930s, period of drought and lots of winds. The topsoil, a good amount of the topsoil was blown away, and some of the areas still are not very nutritious as far as plant growing goes. Don't leave the topsoil barren in windy areas. This is what it looked like. Farmers left, and that's why John Steinbeck wrote The Grapes of Wrath. Is that still happening? Yeah, this is crazy. In 2001, this red over Page, Arizona, was dust, not sand, but dust from storms in China. Kind of crazy. Okay, deflation. Deflation occurs where you get a lot of wind, and little by little, it can blow out fine soil particles. It stops when it hits, well, the water table, like we talked about, I think, in the last chapter. Qatar, Egypt, the deflation bowl there is 250 kilometers long. What is that, 62, 128? About 153 miles long and 100 meters below sea level. Here's what happens. Wind blowing across, when it meets a little indentation, picks up speed. With greater speed, it can carry more stuff, so little by little, it creates what's called a blowout until it gets down to the water table. You think this is a fictional picture? There it is. Here's a blowout. We don't see a whole lot of these in Arizona. Wind-blown rock materials. Oh! Gravel, sand, silt, and clay. Remember that from an earlier chapter? Well, gravel typically doesn't get blown around. Sand can be blown around, and we'll talk about that in a while. It's the silt and the clay that can go up to 40,000 feet. Here's something you see in Arizona. Well, 1, a shoe, 2, twigs, and something called desert pavement. In areas that have constant wind, the silt and the clay and even the sand can get blown away. As those are blown away, only the heavier things are left behind, so you end up with what is called desert pavement. You see this? You know it's a windy area. By the way, look at these polished stones. These are dry canters or ventifacts. Vent like wind and fact like in facet. These are wind-faceted rocks, or ventifacts. Very cool. There's a ventifact. I don't think it's from this picture, but it looks like it. Anytime you see this, it's been wind polished. Imagine you laying out there for a few thousand years and having sand grains blast your face. This is kind of crazy. This is a ventifact, just like this one, but this one is on Mars. So if we see that there, and we see this here, and we know this is created by wind, what can we logically conclude about Mars? It's the principle of, oh my gosh, I just forgot it. Oh well, the things that happen now are the same things that happened in the past, whatever that principle is. Weird. Here's a picture of Mars, June 26, 2001, September 4th, 2001. It has dust storms. And again, we talked about this. Even though water is stronger, it's not all over. Wind occurs all over. If you've ever been to northern Arizona, you know there's a lot of wind. Now, this is kind of cool. You'll see these all over the world. Why does this form? Why does the whole thing get blasted? Well, there's a reason. The same thing this happens. The same thing this happens. The same thing, the Sphinx in Egypt had to be covered by new stone. Why? When sand gets blown across the desert floor, it doesn't go up high up here. It bounces along and actually makes a boinking sound. Boink, boink, boink. Okay, I lied. It doesn't really do that, but it'll help you remember it. Sand typically stays within about 3 feet of the Earth's surface, or 1 meter. So if you're in a sandstorm and you're in shorts and you don't want to get your legs sandblasted, there's a simple solution. Just jump up at least 3 feet and stay there. Okay, maybe it's not a good idea. But now you can see how this rock is being blasted. Eventually, the bottom of this rock will be blasted away and it will, well, become like this. We can imagine that this one time was a pedestal or toadstool rock just like this one. This one is being blasted away, as is this one. Again, the Sphinx, the bottom of it has been recovered because it's been sandblasted by the sands from the Giza Desert, sands deposited by the Nile River. I was here once, and yes, this really is a new coating down here. Notice that most of the heavy stuff is staying close to the Earth's surface. Take a look at the sand in this cross-sectional picture. Here's a ruler, there's a fan blowing the sand, and the sand tends to boink, 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 go across the bottom. The silt and the clay go up higher. Why is this pole wrapped? In the deserts of California, you want these telephone poles to last, so they wrap them with tar paper to protect them from being chiseled away by the sand, again, usually within about 1 meter of the ground. Here's a cool thing. Manganese, I believe it is, and dust in the air can hit sandstone and over time turn it dark. Anasazi Indians, all from 700, 800 to 1200 AD, would come and peck away the dark manganese coating called desert varnish and leave behind their little tag symbols. These are very cool. When you see these, by the way, don't touch them with your hand because the acids in your hand will darken the stone. Appreciate them, but don't mess with them. And don't be like the idiots with the shotguns who feel like they have to blast the rock. Yeah, I really did say that. This is loess. This is stuff that's deposited by glaciers. We don't find it in Arizona because, well, glaciers never came down here, except for one small area around the San Francisco peaks. Hundreds of feet of very fine materials that are deposited by glaciers, and people actually make their houses out of them. You can carve into it. In case that first picture wasn't good enough, here it is again. Here's an example of those houses. It hangs together really well. Remember I showed you a picture earlier of Asian sandstorms, sorry, dust storms, not sandstorms, blowing to North America? This is an example of it. Here's the sand blowing over to North America. Here is loess and where it occurs in the United States. Notice no loess in Arizona. Sand dunes. Let's pause this here and we'll pick it up in just a minute. Oh no.